Right, so for this question, we've got to work out which worker is going to get assigned which task. This is a job allocation problem, so this is when we use the Hungarian algorithm. To use the Hungarian algorithm, we got to follow these 5 steps. So, I've drawn the problem here. Alright, so the first step in the Hungarian algorithm, step 1 is subtract the row minimum from each row. So, minimum number here is 67, so I'm going to take 67 from everything else. And we got to do that for each row, first of all. So next minimum is 35, so I'm going to take 35 from this row, 3, and then I'm going to take 6. Alright, so if we go ahead and do that, the top row will look like 13, 14, 0, and 23. The next row, I'm going to do the same thing, will be 40, 0, 12, and 55. And then if we do the same for the next 2 rows, we get 6, 64, 0, and 81 for the third row. And then for the fourth row, we get 0, 1, 90, and 15. Alright, and then we go on to step 2, which is perform a column reduction by subtracting the smallest number in each column from all the numbers in the column. So for column reduction, I'm going to do that in black. So this column, smallest number is 0. Column 2, smallest number is 0. This is 0. And then column 4 is 15. That means these 3 columns I don't have to change, just these numbers on the end. Which means once we do that, we get 8, 40, 66, and 15. Oh, sorry, 0. That's 0. Alright. Step 4. Cover all zeros with the minimum number of lines. Okay. If the number of lines does not equal the number of tasks, continue to step 5. Okay, so I'm gonna draw a line through here, and then we're gonna, because that covers those zeros, and I'm gonna put a line through here that covers that 0, and then a line through here covers those 2 zeros. So in black, I've got 1, 2, and 3 lines. So let's just rub out all this. I've got 3 lines, and 4 tasks. And it says if the number of lines is less than the number of tasks, continue to step 4. So here we've got 4 tasks, but only 3 lines. So I'm going to go on to step 4. Step 4 is find the smallest uncovered number, subtract this number from all uncovered elements, and add it to all elements that are covered twice. Okay, so smallest uncovered number is 6, which is there. So we're going to subtract 6 from all uncovered elements and add it to all elements that are covered twice. Alright, so let's do that. So this becomes a 7. Taking 6 away from 6 is 0. 14 takes 6 is 8. 64 takes 6. It's 58. 8 take away 6 is 2. And 66 takes 6 is 60. Alright, that's the subtraction part. Now it says add it to all elements that are covered twice. So so the only 2 numbers that are got 2 lines through them is here and there. So 12 and 90. So I'm gonna add 6 to both of them. So this is 18. This is 96. And still have the lines to them. Alright. And then our next step is to cover all zeros with the minimum number of lines. Which means I just need a line here and a line there. The minimum number of lines, so I can work that out. It's 40 here, 0 there, 18, 40. Alright, so minimum number of lines. I've got 1, 2 vertical lines, and then 3, 4 horizontal lines. So there are 4, now I've got 4 lines and 4 tasks. So now I can allocate the jobs. Alright, so alright, couldn't really see it. This with the lines everywhere, so I redrew it. I'm gonna cover up the minimum amount of zeros with the minimum number of lines. So using the 2 vertical lines, I've covered 0 here and 0 there. So now I'm going to use 2 horizontal lines to cover these other remaining zeros. So here we've got 1, 2, 3, 4. That's how I got 4 lines for 4 tasks. So from there, we can draw a graph to represent this information. So we've got worker 1, worker 2, worker 3, and worker 4. We're going to have task 1, task 2, task 3, task 4. So from this table, we can see that worker 1 will take task 3. So from worker 1 to task 3, draw a line there, put that direction in. Alright, next we've got worker 2, and they're going to take task 2. Yep. So worker 2 takes task 2. Worker 3 can take tasks 1 and 3. And worker 4 can take task 1 and task 4. Alright, from this we can see that worker 1 has to be allocated task 3, worker 2 has to be allocated task 2, worker 3, well, worker 1 has to take that, so worker 3 can take task 1, and that means worker 4, employee 4 can take task 1. Sorry, task 4. Alright, once we've got this, go back to our original table. Which we have here. Alright, so worker 3 takes task 1, so that's 67 hours. Worker 2 takes task 2, so 35. Worker 3 takes task 1, 9. And worker 4 task 4, so 21. We're going to add those together to find the minimum time required to complete the task, and that's going to be equal to 132 hours. So it's going to take 132 hours to complete the task by all 4 workers.